Have you ever asked an AI a question, a simple math question, and got an answer that was delivered with total confidence, but was also completely and utterly wrong? Yeah, it's a huge problem. But what if the issue isn't just some random bug? What if it's baked into the very foundation of how AI thinks? And what if we could replace its talent for guessing with an ironclad ability to prove?
Right here. This one word is really the heart of the problem with even our most powerful AIs today: probabilistic. No matter how brilliant they seem, deep down, they're just playing a game of odds, predicting the next most likely word in a sentence. It's an incredibly sophisticated game for sure, but it's still a game of chance.
And this slide really lays out the two sides of the coin. On one hand, you've got current AI playing that high-stakes guessing game. But on the other, there's this totally different approach called deterministic latent logic solvers, or DLLS. Instead of guessing, DLLS treats a problem like a physics simulation that just has to settle into one single logically consistent answer. It's not about what's probable, it's all about what is provable.
So here's what we're going to cover. We'll start with AI's guessing game, then dive into this new physics of truth. We'll see how it actually reasons on a kind of digital canvas, and then get into why this deterministic method just wins out. And, maybe most importantly, we'll ask if this could be a cheaper, more reliable way to build AI and what that means for the future.
Okay, first up, AI's guessing game. I'm sure you've heard the term hallucinations, right? That's when an AI just confidently makes stuff up. And it happens because it's fundamentally designed to sound plausible, not necessarily to be factually correct. This right here gets to the core of it. When a large language model tries to solve a math problem, it isn't actually doing math. It's just mimicking the patterns of what a math solution looks like. It has no real concept of closure, which is a fancy way of saying it doesn't understand that if you know one fact, other facts must logically follow from it. This makes its reasoning brittle and, honestly, a nightmare to try and debug.
So let's pivot to the solution, a new physics of truth. The idea here is, instead of trying to teach an AI to copy how humans reason, what if we could turn a logic problem into a physical system and just let the laws of physics find the right answer for us?
Think of it like this. Imagine you have a stretched-out rubber sheet. A logically wrong answer is like a marble sitting high up on that sheet. It's an unstable, high-energy state. The DLL's model learns to apply a force, a field, that pushes that marble downhill until it settles into the deepest valley. That lowest energy valley is the one and only correct, logically sound solution.
And this is the absolute game changer. An LLM is always asking, okay, what's the next word I should probably write? But a DLS takes a step back. It sees the entire problem, all its parts, and all its logical consequences, all at the same time.